Continuing on with our 13.2 lesson, we're going to talk about the unit circle and radian measure. Now, what is a unit circle, first and foremost? A unit circle is any circle where the radius, so this length right here, is going to be 1. As long as it's 1 or considered 1 unit, then it is a unit circle. That's why we have the points 1, 0 here, or 0, negative 1, 0, 1, negative 1, 0. It's because all of these lengths, the radius is just 1 unit, or a unit circle, which is created here. What is a radian then? A radian is another way to measure an angle, especially in angles of a circle. Now again, using that radius, so the radius would be this length here. If we lay it from the vertex, or should I say the center of the circle, to the edge, that would be 1 radius. But if we were to take that same length and start on the outside of the circle and wrap it around the edge, we'd only get to about right here. So both of these lengths are the same, even though this one is straight and this one is curved. We consider both of them the same length. The angle that is created then has a measure of 1 radian. So 1 radian is the same as taking the radius and just wrapping around the outside of that circle. Now, if angles are measured in both degrees and or radians, we want to know a way to go in between them. So if we're given something in radians, we know how to get it to degrees. Or if we're given it in degrees, we can go into radians. So those conversion factors are going to be these down here. If we are given a radian measure of an angle and we want it in degrees, we'd multiply the number of radians by 180 degrees over pi radians. So if I had pi radians and I wanted it in degrees, I would simply multiply by 180 divided by pi, in which case, call this like pi over 1. Our pi's would cancel, and we'd just be left with 180 over 1, or we could say 180 degrees. So this point over here is both, if we have our angle, we'd call it 180 degrees, or we could call it pi radians. And vice versa. If we were given something in degree measure, we would just then multiply by pi radians over 180 degrees. You can go back and forth between the two. So if we want to look at how many radians in 1 revolution of a circle, well, we know that there is 360 degrees in 1 circle. So we would have to multiply that by pi over 180, in which case our answer would come out to this 360 over 180 come out to 2 pi. It's always okay to leave your radian measures in terms of pi instead of spelling it out. So 2 pi would be like 2 times 3.14, in which case we'd have about 6.28. Don't actually say the 6.28. Leave it in terms of pi. That's 2 pi. So if we wanted to convert these to radians, we already did this one actually. The 180 degrees is the same as saying pi. What about 90 degrees though? 90 degrees, we would have to multiply 90 times, again, our pi over 180 to get our radian measure. 90, and we can take out 90 from here, in which place we'd be left with 2. So we would have pi over 2. Same thing if we had 270 degrees, 270, and we need to convert it to radians. So we multiply by that conversion factor. 270 over the 180 is going to reduce down to 3 over 2, still multiplied by our pi, so it would be 3 halves times pi, or a lot of times you'll see it written as 3 pi over 2. Either one is acceptable. And if we wanted to convert to degrees, we have pi radians, so we would take pi times 180 over pi. I think we already did this one as well. The pi's cancel out, in which case we have kind of a hidden 1 here. It's like 1 times pi. So we'd have 1 times 180, 180 degrees. Pi radians is 180 degrees. So again, anytime you need to convert these things, here are your conversion factors. Getting those out of our way, if we wanted to do a little more example work here, we would take 135 times pi over 180, in which case we would be left with the 3 pi over 4, because 135 over 180 is going to be 3/4. Similarly, if we did 240, we want to convert that one as well, pi over 180. So 240 over 180, same as saying 1 1/3 times pi, or we can say it's 4/3 times pi, or we can write it as 4 pi over 3. All three of them are acceptable. You'll probably most see it written this way: something times pi over something, so 4 pi over 3. Those would be our answers there. If we wanted to go, in these cases, from our radians to our degrees, in this case we'd have to multiply by 180 over pi. I'll get our conversion factor ready on this one. So 7 pi over 4 times 180 over pi. If you need a calculator, that's fine. This one's going to come out to 315. This one, the pi over 3, or 1/3 pi, times our 180 over pi comes out to 60 degrees. A coterminal angle to 7 pi over 3 is, remember to find coterminal, we always either added or subtracted 360 or 360 degrees. So if we're given something in a radian measure, we don't want to use 360, we want to use a radian measure for that. 360 degrees, remember we said was 2 pi. So we're either adding 2 pi or we're subtracting 2 pi. So our 7 pi over 3, if we wanted to add 2 pi, we would say 7 pi over 3 plus 2 pi. I'm going to change that into thirds right away. That would be 6 pi over 3, because 6 over 3 is 2, in which case we would get to 13 pi over 3. So that will be one of them. Oops, I want 13 pi over 3 is one of our coterminal angles. Or, if we wanted to go the other way, so we'd have 7 pi over 3 minus 6 pi over 3. So again, in one case we added our 360 degrees, or our 6 pi over 3. In the other case we subtracted our 360 degrees, or 2 pi, or the 6 pi over 3. So we'd be left with pi over 3. So these are our two answers here. And that would take us next then to the unit circle.